so the learning objectives for this segment will be to understand why ionic compounds precipitate and to predict whether a reaction of ionic species will result in a precipitate or not. So as you've noticed in the reading, there's a lot of complicated rules, like why carbonates in this case and why not in that case. And so we have to think about what exactly is going on in precipitation. So anytime you put an ionic compound in solution, it's a tug of war. And what is the tug of war in between? Which is more important? The ions like being next to each other more, or do they like being solvated by water more? That's fundamentally what's going on. If the ions prefer to be solvated by water, it will be soluble. If they prefer to be next to each other, if that's lower energy than having all the ions surrounded by water, then it will precipitate. And it's a very complicated tug of war. There's a lot of things like how large the cation is, how many waters can fit around it, how large the anion is, what the total charge are, even what orbitals the electrons are in. We'll get into that later. So it's very complex. It turns out there's no great ways to just look at a compound and say, aha, well, I know that because it has this number of electrons, therefore it will be soluble. There are lots of trends, though, and so we can make rules out of the trends. So what we have to accept is it's a tug of war. There's a lot of different things going on, a lot of different energetic effects. But how big it is, how many waters can fit around, how close the waters can get, a lot of things. We can't go into them. There's no way we could. But what we can do is learn the trends and be able to apply the trends. So there's a relatively small number of rules that cover most compounds. So ionic compound is probably soluble. I'd say it's more than this. There's not that many exceptions. It's almost certainly soluble in water if it contains one of the following ions. A group 1A cation, like lithium, sodium, potassium, cesium, rubidium, or also ammonium, which is obviously not a group 1 cation, but ends up being a pretty good indication of solubility. Nitrate, acetate, perchlorate, these all are quite highly likely to lead, these anions are highly likely to lead in soluble molecules. Sulfate usually is soluble except with certain metals. Calcium, strontium, barium, lead, and mercury, the mercury 2 ion. Why these? They're 2+ ions, so if you have big ions, +2, -2 charge, sort of makes sense that they would they like to stick together more, but magnesium is +2 as well, and it is soluble. Magnesium sulfate is soluble. So you have to say, okay, fine, these are the rules. Halogens, chlorine, chloride, bromide, and iodide ion, except with certain metals. That they're soluble except with these certain metals. So if you recognize any of these, you say, aha, it's almost certainly soluble with a few exceptions that are listed here. Then also, it's probably insoluble in water if it contains one of the following ions. The sulfide ion, except with group 1A cations and NH4. So the rule we talked about before is more important. Carbonate, except with group 1 cations and calcium, strontium, barium, a few here. Phosphate is usually insoluble except with group 1A cations and NH4+. OH- is usually insoluble except with group 1A cations and NH4+. Yeah. Calcium, strontium, barium. So these are, as opposed to the previous page where almost everything was soluble, almost everything in these are insoluble. And that gives you enough guidelines for almost any of the aqueous ionic solutions you'll see. There's just, there's only a limited number that occur with common ions. So with this information, you can predict almost anything. And you'll see slightly different versions of solubility rules. And so on an exam, I'll give you a list of solubility. I won't make you memorize the solubility rules because they can be looked up. You should just be able to recognize. What I would expect you to do, if a reaction is occurring, for you to check if something is soluble or not. So you'll have solubility rules accessible, but I won't necessarily tell you to see if something is soluble or insoluble. You'll have to remember to check to make sure if it's an aqueous reaction, is there going to be some sort of precipitation going on? So, because I think that that's the way it is in the real world. It's like you got all the information there to look up, but you better remember to look it up. So those are the example of the rules. You might see slightly different versions of the rules. They'll mostly be like this because they'll just might not include or include a couple other ions to be concerned about. So let's look generally how one would apply them. Okay, clicker question. Okay, it's not a clicker question this year. We'll walk through it. Actually, no, you'll walk through it first. And it might take a couple minutes to go through all the way. And then we'll go through together. So pause, think about it, and we'll go through. I won't pass that long. I'll just let you pause. Okay, so let's take a look at these. What I like to do, I find this the easiest way to keep track of things, is to make a little grid. So in this case, so we're going to make a little grid like this. So let's take a look at the first one, and I'm going to make a 2x2 grid, 2x2 grid, and I'll have the anions up here, CO3 2 minus, Cl minus, and the cations here, zinc and potassium. So let's look at the rules. Well, potassium is a group 1 cation, so essentially anything will be soluble with that. So yep. We can check those out as soluble. Chloride is usually soluble except in a few special cases, but zinc doesn't fall under that. So that's soluble as well. Zinc carbonate. What about zinc carbonate? Well, if we go back here, carbonates are going to be insoluble except with group 1 cations, calcium, strontium, barium. Zinc's not on that list. So therefore, this does produce a precipitate. That is an insoluble combination. Okay, so right there it's zinc carbonate that will drop out. Okay, let's do the same thing here. We draw our little grid with, now the anions are NO3 2 minus and I minus, and the cations are lead, Pb2 plus, and potassium. Okay, so again, potassium, soluble, and iodine. Let's check and see, let's go back, because iodine is usually soluble, but there are exceptions there. Iodine soluble except with silver, lead, mercury. Okay, lead iodide is insoluble. Nitrates are essentially always soluble. If we go back and check, yeah, nitrates are essentially always soluble. This is going to be soluble. So lead, PbI2, is insoluble. Check the demo of a recording of a demo. This is I like doing in class, but can't do it this time. Of lead, I think it is lead nitrate, and potassium iodide, both colorless solutions. You put them together, and you get this brilliant yellow lead iodide precipitate coming out. So the version I posted on the web of someone else doing it has some very nice background music. It's just very peaceful watching, you know, the precipitate drift into existence and drift down to the bottom of the beaker. So that if you need some calm, relaxing chemistry, then watch that for a minute or so. Okay, so that's the next one, and then we look at the last one. And we have perchlorate, Cl4 minus as one anion, bromine as another, and then silver and silver plus and calcium 2 plus are our cations. All right, so chlorate, let's go back and look. Chlorates, oh yeah, the perchlorates, there we go. These are almost always soluble. So soluble. Bromine, again, bromine soluble except with silver, lead, mercury. So this is soluble. However, Silver bromide. No, no, no. Silver bromide right there. We see silver and bromide here. So right here. So that's no good. That is, nope, sorry. Silver, there we go, and bromide. So that is definitely going to be a precipitate. So silver bromide, which actually silver bromide, precipitating silver bromide is actually part of the key of sort of the original photography. So silver halides, especially silver bromide, were the first compounds used in order to do black and white photography. So that's important historical chemistry. Okay, so we can see that all of the reactions produce a precipitate. B is the right answer. Okay, so that's the sort of thing I'd expect you to be able to do and be able to recognize the precipitate, to remember to look for it. Otherwise, yeah, it helps to like sort of memorize these things. Like what are the things that are almost like the fact that, you know, if it has potassium in it, it's probably going to be soluble. You know, those are things that you should remember those, but I won't test on it without a solubility chart.